students, in this video class we are going to continue the chapter data handling. In particularly, we are going to learn about chance and probability, the last exercise of this lesson.
Chance and probability. Sometimes it happens that during a rainy season you carry a raincoat every day and it doesn't rain for many days. However, by chance, one day you forgot to take the raincoat and it rains heavily on that day. Sometimes it so happens that a student prepares 4 chapters out of 5 very well for a test. But a major question is asked from the chapter that she left unprepared. Everyone knows that a particular train runs in time, but the day you reach well in time, it is late. You face a lot of situations such as these where you take a chance and it does not go in that way you want it to do. Can you give some more examples? These are examples where the chance of a certain things happens or not happens are not equal. The chance of train being in time or being late are not the same. When you buy a ticket which is wait listed, you do take a chance. You hope that it might get confirmed by the time you travel. We, however, consider a certain experiments whose results have an equal chance of occurring. Getting a result. Next, we are going to see about getting a result. You might have seen that before a cricket match starts, captains of 2 teams go out to toss a coin to decide which team will bat first. What are the possible results you get when a coin is tossed? Of course, head or tail. Imagine that you are the captain of one team and your friend is captain of another team. You toss a coin and ask your friend to make the call. Can you control the result of the toss? Can you get a head if you want one or a tail if you want that? No, that is not possible. Such an experiment is called a random experiment. Head or tail are the 2 outcomes of this experiment. Let us try these questions. If you try to start a scooter, what are the possible outcomes? The scooter may start or may not start. Second, when a die is thrown, what are the 6 possible outcomes? 1, 2, 3, 4, or 5, or 6 are the possible outcomes of a die is thrown. Third question, when you spin a wheel shown on screen, what are the possible outcomes? List them. The outcomes here means the sector in which the point stops. You can see that on the picture there are 3 sectors named A, B and C. So that the possible outcomes are A, B or C. Question 4. You have a bag with 5 identical balls of different colors and you are to pull out a ball without looking at it. List the outcomes you would get. If you see that there are 5 balls named, colored, white, red, blue, green, and yellow. So the outcomes are red ball, white ball, green ball, yellow ball, or blue ball. These are the outcomes we get. Think and discuss and write. We can do some questions on it. In throwing a die, does the first player have the greater chance of getting a 6? No, it is not, certainly not. The second question, would the player who played after him have a lesser chance of getting a 6? No, not exactly. Okay, because the player who played after him also get the equal chance of getting a 6. Suppose the second player, third question, suppose the second player got a 6. Does it mean the third player would not have a chance of getting a 6? No, it doesn't mean that, because the third person also have the equal chance of getting the number 6. The next we are going to see equally likely outcomes. A coin is tossed several times and the number of times we get head or tail is noted. Let us look at the result sheet where we keep on increasing the tosses. Observe that as you increase the number of tosses more and more, the number of heads and number of tails come closer and closer to each other. This could also be done with a die. When tossed a large number of times, the number of each of 6 outcomes become almost equal to each other. In such cases, we may say that the different outcomes of the experiment are equally likely. This means that each of the outcomes has the same chance of occurring. Sometimes a coin can be placed vertically like this on the screen, or a die can be placed between a corner hitting a wall like that on the screen. Don't worry, such cases will not be considered as the probability is very small for these cases. Linking chances to probability. Consider the experiment of tossing a coin. What are the outcomes? There are only 2 outcomes, head or tail. Both outcomes are equally likely. Likelihood of getting a head is 1 out of 2 outcomes, that is 1 by 2. In other words, we say that the probability of getting a head is equal to 1 by 2, which is probably getting a tail. What is the probability of getting a tail? Now, take the example of throwing a die marked with 1, 2, 3, 4, 5, and 6 on its faces, 1 number on one face. If you throw it once, what are the outcomes we get? The outcomes are 1, 2, 3, 4, 5, and 6. Thus, there are 6 equally likely outcomes. What is the probability of getting the outcome 2? It is 1 upon 6. 1 is the number of outcomes giving 2. The 6 is number of equally likely outcomes. What is the probability of getting the number 5? What is the probability of getting the number 7? What is the probability of getting a number 1 through 6? These questions you can answer by your own. Next, we are going to see outcomes as events. Each outcome of an experiment is a collection of outcomes make an event. For example, the experiment of tossing a coin, getting a head is an event, and getting a head tail is also an event. In case of throwing a die, getting each of the outcomes 1, 2, 3, 4, 5 or 6 is an event. Is getting an even number is an event? Since an even number could be 2, 4 or 6, getting an even number is also an event. What will be the probability of getting an even number? It is 3 by 6. 3 is the number of outcomes that makes the event of getting an even number. 6 is the total number of outcomes of. Example 3. A bag has 4 red balls and 2 yellow balls. The balls are identical in all respects other than color. A ball is drawn from the bag without looking into the bag. What is the probability of getting a ball, a red ball? Is it more or less than getting a yellow ball? This is the question. We see the first example as a first example in probability. Solution, we can see that there are in all 6 balls, 4 red, 2 blue balls, total 6 balls are there. So there are in all 6 outcomes of the event. Getting a red ball consists of 4 outcomes. Why? Because there are 4 red balls are there. Therefore, probability of getting a red ball is 4 upon 6, which is equal to 2 upon 6 or 2 upon 3 or 2 by 3. In the same way, getting a probability of the probability of getting a yellow ball is 2 upon 6, which is equal to 1 by 3, because there are 2 yellow balls are there. So getting yellow balls is 2 by the total number of outcomes of the experiment is 6. So 2 by 6. 6 balls are there. Only the probability of getting a yellow ball is 2 by 6. Therefore, the probability of getting a red ball is more than that of getting a yellow ball. While comparing, we can see that number of red balls is more. Let us try this. Suppose you spin a wheel, which is shown on the figure, then we can answer the questions. First one, list the number of outcomes of getting a green sector and not getting a green sector on this wheel. So the number of sectors we get a green, we can see it is a 5. Non-green, not getting a green, that is 3 red, 3 R's are there. So it stands for the 3 number of not getting a sector, green sector is equal to 3. Second question, find the probability of getting a green sector. So there are 8 sectors are there when you count, in that the possible outcomes for green is 5. So it is 5 by 8. Find the probability not getting a green sector. Not a green sector is 3 sectors are there. So we can say that 3 upon 8. This is the probability of getting a not a green sector. Next, we are going to understand the chance and probability related to real life. We talked about the chance that it rains just on the day when we do not carry a raincoat. What could you say about the chance in terms of probability? Could it be 1 in 10 days during a rainy season? Probably that it rains is 1 by 10. The probability that it does not rain is equal to 9 by 10. Assuming raining or not raining on a day are equally likely, which means we are assuming here in a day it may rain or it may not rain. We have kept 2 chances there, such that there are 10 days like that. The use of probability is made in various cases in real life. First one, to find the characteristics of a large group by using a small part of the group. For example, during election, an exit poll is taken. This involves asking the people whom they have voted for. When they come out after voting at the centers, which are chosen of and distributed and over the whole area, this gives an idea of chance of winning of each candidate, and predictions are made based on it accordingly. Second, meteorological department predicts weather by observing the trends from the data over many years in the past. Dear students, we are going to understand about the playing cards. In a pack of playing cards, if you see, there are 52 cards will be there. It is called as a deck of cards. In a deck of cards, there will be 52 cards. The first set, we say it is we see this shape as it is a spade. Okay, the suit of a spade, there will be 13 cards. This card we say it is an ace card, so we keep it here and we can see the remaining cards of it. So we have the numbers, so 2 to 10 cards will be there. 7, 8 and 9 and 10. After this we have the cards Jack, Queen and King. So these 3 cards are called as face card, face, Moham. The reason is you can see here a picture is there, so it is called as a face cards. So including this, there are 10 cards, 9 numbered cards and 1. Instead of 1 we have ace card. So then we have Jack, Queen and King. So the spade, which is in black color. So after that we can see this ace card of heart shape. So next one, heart, the suit of heart. That one same way we have 13 cards. So ace, then numbers 2 to 3, 4, 5 6, 7, 8, 9 and 10. Then we have again the jack of heart, the jack of queen, jack of heart and queen of heart, then king of heart. After that we have the flower shape, okay, or we say it is a club shape, club, the suit of club, which is also having the 13 cards. So we can see all the cards from here, so that all cards and the jack, queen and king. So we have such 13 cards here. So I'm going to keep this here, okay, 13 cards the same way. Then we have diamond shape, from the heart to all cards here we can see the 1 to 10 and jack, queen, king, okay, so like that. So we have here, so total there are, so we have a set of 52 cards, 13 here, 13 and 13 and 13, okay. So 13 plus 13, 26, then plus 26 plus 13, 39 plus 13, 40, 52 cards. So we have total 52 cards here. If you see the ace card, we have 4 ace cards, okay, and if you see the number of black cards, 13 plus 13, so we have 26 black cards. And the red cards, we can see the 13 plus here on 13, so we can see 26 red cards. So number of black cards 26, number of red cards also 26. The number of face cards, how many face cards are there? We can see that, we can see 1, 2, 3, 4, 5, 6, here 3 cards are there, 7, 8, 9, here also we can see the 3 face cards. So 10, 11, 12 face cards are there. How many kings we have? 1, 2, 3, 4 kings are have. Queen also 1, 2, 3, 4 queens and jack 1, 2, 3, 4 jacks are we have. So if we can ask you may ask the probability of finding any card. So for example, probability of finding an ace card, finding a ace card, only one ace card, ace card is asked. So how many ace cards we have? 1, 2, 3 and we have 4 ace cards here. So probability of getting a ace card is, there are 4 ace cards, so 4 by the total cards is 52, so it is 4 by 52 if in the case of ace card. If we are asked to find out the queen of red color, queen of red color, how many queens have we? Have 4 queens, but in red color we have 1 and 2. So the queen of red color, so there are 2 red queens are there, so 2 by 52 cards, 2 by 52, when you simplify we get 1 by half of it, so that is 1 by 26 cards that is the probability of drawing it. If he has to find out what is the probability of drawing a king, so there are 4 kings are there, so 4 by 1, 2, 3, 4 kings, 4 by 52 cards. When you simplify we get 1 by 13. 4 table we can simplify, we get 1 by 13 here. The same way any cards we can ask in the question, okay. So what is the probability of getting a black card? So there are 13 plus 13, 26 black cards are there. So 26 divided by the total is 52, that is 26 divided by 52, that we can simplify we get 1 by 2. So in 52 there are 2 26 are there. So 26 plus 26, we get 52. Okay, hope you understood all the cards here. This is the cards. So this is a suit of spade, this is a suit of heart, this is a suit of diamond, this is a suit of clubs. So each suit have 13 cards. The total we have 52. Hope you understood. From the cards we can select, from here we can understand how to do the probability. Thank you.